All right, guys, we are going to work on integrated rate law graph analysis. So before this, you were introduced to the three integrated rate laws, the three equations from our equation sheet, first three, and you looked at how to use those to find the concentration of a reactant at a specific time, or used it to find your rate constant, things like that. So these are graphs that are produced from those equations, and we're going to see how these graphs can help us determine the order of our reaction. So we're going to start with zero order. So we're going to look at the graph here, and then we are going to analyze it using the questions and figure out what it's telling us. So we can first, it says part A is to circle the units of measurement of the y-axis. So here our units of measurement are moles per liter, which is another way of saying molarity. And you can see that this is that the graph is the concentration of our chemical, so that's why it's measured in molarity. Now the next question is the graph or the line graph straight? And the answer is yes, it is a straight line. So when we have a straight line produced from a concentration versus time graph, so concentration on the y-axis, time on the x, we can find the slope of that line. And that slope is going to, or the negative of that slope is going to represent the rate constant. We say the negative of the slope because our rate constant needs to be a positive value. In this case, we can see that the slope of our line going down is negative. It's a negative slope. So we got to flip the sign essentially. So we want to find the value of the rate constant, which means we want to find the value of the slope. So the way that we do that is the change in y over change in x, just like you would do in your math class. So we can pick 2 points on the graph, and I usually like to find two that are pretty easy to figure out what their values are from the graph. So we've got this one is pretty easy because it's like right on a axis where the 2 points intersect. And let's go ahead and go with, I think this one's good. It's pretty much on a line. Let's do those two. So our y values. So we want to do y2 minus y1. So our y2 would be this one here. So 2 and 1. So our y value for 2, these are going by 1, 2, 3, 4, 5, so 0.01. So we're at 0.03, maybe a little bit above. So 0.031 maybe. Excuse me. Minus the one here, so 5, 6, 5, 6, 7, 8, 0.08. 0. All right, and our y values are measured in molarity there. And then our x values. So this would be our x2 would be about, I'd say about 56 seconds. Minus x1 would be 40 seconds. So when we do that, we're going to use our calculator and calculate. So you can use yours to practice it. We don't have to do this type of calculation a lot, but I did want you guys to see it. Divide that by 56 minus 40, 16, and I get, and remember it's the negative of this, so we want to flip the sign. So we get 0.003. And that would be molarity per second. Since we are doing the y value over the x, we get our units for that. So y over x is molarity per second. So we can find the slope. So this is our value for our rate constant, which is pretty nice. So it says when the graph of the concentration of our chemical A versus time is a straight line. The order of the reaction is 0, 0, because the rate or slope does not change over time. We can see that in that graph there. So our line is straight. We have the concentration over time. That is a rate. That's our rate constant. It is a constant rate, so 0 order. So our big takeaway here is going to be where our stars are. So when we get a straight line, when the y-axis unit is molarity, it's 0 order, or when it's the concentration of A. Okay, it has to be a straight line. Okay, so that is our first one. Now we're going to see how this changes for a first order reaction graph. So we're going to take a look at this first graph. It says circle the units of measurement of the y-axis of the first graph. So our units here, we got molarity, moles per liter again. So molarity. Is this straight? This is not a straight line. So that indicates that the concentration over time, the change in concentration over time is changing. We have a changing slope. It is not constant. If it was constant, it'd be a straight line. So that indicates that it is not 0 order. Okay, it's not straight. Okay, so it's not 0. Doesn't equal 0 order. So now we're going to look at the next one. Circle the units and measurement of the y-axis on the second graph. We have the natural log of A, which means we have no units. Remember, when we take the natural log, it takes away that molarity. So no unit. So is this straight? Yes, we get a straight line here. Okay, the negative of the slope of the line represents the rate constant. Find the value of our rate constant. So we're going to pick 2 points again and find our rate constant. This one is, let's pick 2 points. What looks good? That one looks pretty close to some places where they intersect. And that one's on a line. That looks nice. So I'm going to do that. 2 and 1. Okay, so y2 is going to be here-ish. Oh, no, not there-ish. Where's that? Okay, it's going to be about there. So that's going to be 0.4, 1, 2, 3, 4. So these are going by 0.2. So it's going to be about -3. Oh, we are negative, so we're going the other way. -3.1 minus negative, let's see, 2.6. Okay, no units there because it's our y-axis. And then our x values would be, let's see, we've got about 15 minus 10 seconds. And again, we're going to make this whole thing negative, change the sign. So 3.1, -3.1 minus -2.6 divided by 15 minus 10. I'm going to flip the sign. I get 0.1. And that is 1 seconds. Okay, now I know these are some estimated calculations. You're not going to have to do this type of calculation a whole lot, if at all. The general thing is that we want to know that we can find our value k from the slope if we needed to. And that's what it means. So when the graph of the natural log of A versus time is a straight line, the order of the reaction is first order. So we get a straight line. When we get a straight line, when y-axis unit is 1/seconds, or excuse me, no unit. we get no unit, it's first order, or if you see the natural log of A and it's a straight line. Okay, it's first order. So if we were to graph the concentration versus time like the first graph, and we get a straight line, it's zero order. If we don't, they take the natural log of the values. Graph it. If we get a straight line, it's first order. Last one, second order. So analyze these. Circle the units. So they did the molarity, so concentration versus time. Do we get a straight line? No. Then we did natural log versus time. Do we get a straight line? No. So it's not zero order. It's not first order. So our last one, we get 1 over A versus time. And we get a straight line. Yes. Slope of our line, since it's a positive slope, it's going up. So the slope equals our K value. So again, we can find the value of K. So I'm going to pick that point because it's nice and obvious. And that one's nice and obvious. 2, 1. So Y2 is here. So 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34. That's not at the scale. Let's see. Every 5 is 10. So 1, 2, 3, 4, 5. That's going to be 20. Let's see. No, every 4 is 20. That's weird. Okay. So 10, 20, 30. So we're halfway between 20 and 30. Okay. So that means we are at 25 minus the first one, which would be at 20, 10, 20, like 18-ish. And the concentration is 1 over A. So that would be 1 over the molarity divided by, our time is 200 seconds minus 1, 2, 3, 4, 5. So 120 seconds. All right. Awkward math. Divided by 80. Oop, can't divide by 0, Sarah. Yes, I'm talking to myself, guys. It's okay. My calculator's not cooperating here. There we go. Okay. When I calculate this, I got 0.09. If we're rounding here, and then we got 1 over molarity here and seconds on the bottom there. So we got molarity times seconds on the bottom, which are units for K for second order. So we get that. All right, so we can always estimate our slope from our graph once we know what order it is. So this is second order. So when the graph of 1 over the concentration of our chemical versus time is straight line, the order of the reaction is second order. When our y-axis unit is 1 over molarity, it's second order. Okay, so I know this is kind of random, but the biggest thing is that we can take a graph, look at its y-axis, and determine what order it is. So if we look at one of our graphs, we can see that this first one for part A is a straight line. Then we can look at its y-axis. It is 1 over the concentration. So 1 over A. For 1 over A versus time to give us a straight line, it has to be second order. Okay, so that's how you're going to do the practice. You're going to look at what your y-axis unit is and determine what does that tell me. Okay, so it's pretty straightforward. It just gives us a way to find the order based on the graph. You will see multiple choice questions or FRQs like this. There's one, I believe, last year, a free response question where it gave like all 3 graphs, kind of similar to this page. And it asked you to determine the order of the reaction based off the graphs. And it was very straightforward. So just another tool based on that. Thanks, guys.